G'day there, you're watching the Aussie Guru, and today we're going to run through the second part of a small series I've set up on tagging. So we're looking today at tagging all elements in a room using Dynamo. So thanks again to Sharon for her troubleshooting and testing on this topic. She's helped on all three parts of this, so I really appreciate that. So in part one, we looked at tagging all elements in a view using Dynamo, which is quite good for a floor plan. But for other views it won't work so well. So I'll show you why at the beginning of this tutorial. So tagging, it's a real bore, and Dynamo is great at making boring tasks go away. So this is a three-part series. The final part after this one will deal with adding a user interface at the end of the script to really let the user pick exactly what they want to tag in their view. So previously we looked at refining the tag all function using Dynamo in order to tag all elements we could see in a view. The script doesn't position all the tags perfectly. That's something that still is a manual exercise, but it does at least save half of the clicks that we have to do whilst we tag. And the great thing about this versus tag all is that it doesn't tag things that don't have a value to tag, such as walls and doors. So that's where tag all sort of fails versus this. So previously we ended up with a script, so I recommend that you go and watch the first video and build this little script, or just send me an email and I'll send you a small demo that you can work along with for this part. So there's an issue with the script that we built last time, and it tags exactly what Dynamo sees. That sounds like a good thing, but it's not, because Dynamo sees more than we do. So you'd expect it to tag like it does on top, maybe not quite as neatly, but what we get down the bottom is a lot of tags. So it tags a lot of things that we can't see, but Dynamo can. So you can see things like chairs are being tagged there. I don't see any chairs in that elevation, so I'm a little bit confused. So the first time I saw this was sort of my reaction. What's going on? But what's actually happening is Dynamo is seeing everything in the active view. So it doesn't care if something's in the way. So what's happening is that the view range of the elevation in this case is deeper, and it actually sees the chairs in the next room and it tags them, so the wall doesn't block this. So we need to find a way to limit how much Dynamo can tag. So we're going to adjust our script to a selected room only, which is really helpful for room elevations. And we're also going to build it so that we can run it through Dynamo Player so that we can do a set of elevations in a row. So the way that our script worked before is that we took all the tags in a view, found all the tagged elements, and then we took the elements in that view and said, does it have a value that can be tagged? We took all those elements and said, is it tagged? If it wasn't, tag it. What we're going to do now instead is we're going to take a room as well as a separate function, and we're going to also check if the element occurs in the room and filter it out before we check if it's tagged. That way we know that we're only dealing with elements that exist within the room that we want to tag. So that will stop things being tagged in the walls behind the room, for example. So we're not going to be using any new custom nodes today, but we will be using the ones in the script from before. So you will need these two custom packages in order to run the script. And ideally, if you can use 2.0.3, that's better, but anything in 2 and beyond should be suitable. So without further ado, let's go and improve our script in order to be able to tag more types of views. So this is where we ended up last time with our script. So what I've done is I've just set up an elevation that we're going to try and tag using Dynamo. So as I said before, if we run our previous script, it will tag too much. So if I run our previous script and I go and check on the results, you can see we've just tagged a lot of things. So we have about 15 elements we've tagged here. I can only see 5, 2 pinboards and 3 outlets. So what we're really tagging is all the chairs and tables behind here. So I'm just going to get rid of all these tags, and we're going to adjust this instead to suit a better way of tagging this particular view. I do recommend keeping the old script as a good tagging tool for like a floor plan, where you know that your view range is going to stop you seeing things underneath the view range. But in elevation, it's a bit different. So we're just going to start with our previous script. Okay, so the first thing we're going to do is we're going to go and build this set of nodes down here, which are going to go and predefine the room and find out if the elements are within the room. So the first thing I'm going to do is just freeze this last node so that we don't tag whilst we test and run this script. What we're also going to need to do is we're going to need to take this set of nodes here. So the way that these nodes were working is they were checking the location of the elements that we were able to tag. And then from there, we were just filtering it to check that the location of the element was represented by a point. This was to remove things like skirtings and walls, whose location is represented by a line. But what we need to do is actually move this earlier in our script. So I'm actually going to disconnect this part of the script. And then we'll reconnect this later differently. So we're going to take this little part of the script and put it off to the side. And what we're going to do is we're going to get another element get location node. I'll actually just copy this one here, but we just need an element get location. And our output here, I believe, was coming out of our out list. Because basically this is the point where we say, is this element tagged in the view? If not, it goes through our out list, and then we tag it. So we're going to take the elements and the location, and we're going to feed the elements back into this node here, and the locations back into this node here on our tagging node. But we're going to move this filtering condition earlier in our script, because we're going to need to check the locations of these elements to find out if they occur in the room. So that's really important. So the first thing we're going to do is we're going to come back here, and we're going to start building this part of the script to read our room geometry. So we could just use room and element geometry, but the problem with this is that sometimes elements sit just a little bit outside the wall. So we're actually going to process our room geometry in a bit more of a complex manner. So the first thing we're going to do is we're going to get a select model element node. And this is where we can select our room. So I'll just minimize this, and I might be able to see the room in this view, which I can. So I'm just going to isolate this to make it easier to select. Select model element, and I'll pick my room. Now we have our room that we can play with in Dynamo. So for those that don't know, you can just go element geometry, and the geometry of a room is always represented by its volume as a solid. So you'll see here, this is my room in in Dynamo, and in Revit you'll see that it's represented as a blue box whilst you work with it. You'll note that it's represented by the limit offset of the room, which is 2.7 in this case. So just be mindful, you need to make sure your limit offset is correct. So it needs to match your ceiling height or be higher and your ceiling bounds the room. Okay, well, we're not going to process this because the problem is this is representing the room up to the finished face of the room, which isn't ideal. Obviously, if you bound your rooms based on centerline, it would be based on that instead. So for those that don't know, in your room property settings, I think it's under architecture, room and area and volume computation, you can actually set your room volumes to be calculated at various locations of your wall, such as wall center. But usually I work with wall finish in most project typologies. That way you're not contributing the area underneath the wall, even though some measurement strategies let you do that. But anyway, what we're going to do instead is we're going to process the bounding box of the room. And the reason we're doing that is we need to find out the height of the element that we're dealing with. So the bounding box doesn't actually represent anything that we can see in Dynamo, but we can convert it to a cuboid to see it temporarily. So the bounding box is essentially an element that contains that room. If the room was at an angle to Dynamo, the bounding box would still be at Dynamo North. But essentially all we care about is the height. And the reason why we're getting a bounding box is we want to get the bounding box minimum and maximum point. So the minimum point is essentially the closest point in the X, Y, and Z direction to the bottom left in Dynamo, and the max point is to the top right. And all we care about is the Z value in this case. So I'm just going to delete my bounding box. Actually, I'll keep it there just for now so you can see where the points show up, because we'll get 2 points out of this. And there you go, you see we got our minimum point and our maximum point. But all we care about is the Z value. So we're going to get point Z to get the Z component of that point. And this is just so we can find out the height of our room that we're going to need to compute, because we're going to make our room a little bit bigger and then loft its form. Okay, so what we're going to do is just set up a sum now as well, so a minus sum, and we're going to do the maximum minus the minimum. So I might just swap these around just so my nodes don't cross over each other. So our maximum Z minus our minimum Z should give me the height of the room. And there you go, 2.7. You could also get the limit offset, but maybe your room has a base offset as well. So it's usually safer to do this, I find, to process the geometry. Now we're going to go back and we're actually going to get the room's finish boundary. So this will be represented as a set of lines or curves. So if I run this, you'll see that we get this line here. I might just turn off these bounding box minimum and maximum points so we can focus on this. And what we'll get is a set of curves. So essentially we need to turn this into a polycurve by joined curves, just to turn it into one continuous line. And there you go, we get a polycurve with 5 curves in this case, which is interesting. There must be a very small little crook in this line somewhere, because it feels like I'm looking at 4 lines there, so that's quite strange. Anyway, we'll ignore that anyway. So what we need to do now is offset our curve, because we're going to make our room just a little bit bigger to reach those elements that might be inside the wall. So these could be things like recessed panels, such as an X-ray panel in a hospital, which is typically inside the wall rather than on the face of the wall, so it's not actually inside the room, it's a little bit beyond the room. You could obviously set up reporting points and use a different method to find those elements, but I find that can be quite unreliable in Dynamo. What we're going to do now is set a tolerance to go beyond. So I'm just going to make this a number parameter, and let's just make this 125. So if I feed this into my curve offset and I run this, you'll see that we get a offset curve. So I'll just go into geometry mode, and there you go. You'll see this is our returned curve that comes out as a result. So it's a little bit beyond the room's extent. Obviously, if you ever need to process room geometry, you can also offset negatively as well to offset inwards. Okay, so we're just going to hide our polycurve and our curves of our finish boundary. So now we're dealing with a slightly larger zone. But what we need to do now is translate this curve up by the height of the room. So we're going to get a geometry translate node, because we're going to loft these 2 forms together into a new solid. So we're going to translate geometry by direction and distance. So we're going to take this curve as our geometry. We're going to move it by this much distance, and we're going to do it along the z-axis, so straight up. There we go. So now we should get a curve above the room. And there you go. Okay, so what we can do now is we can join these 2 together. So there's a couple of ways you can do this with 1 or 2 nodes. The way I've found you can do it with just 1 node is to use an add item to end or front. And what you do is you take the upper curve, so I'll just move that a little bit out of the way, and you take the lower curve, and you say to add the item to the end at level 1. So within this list, insert this other element. Oh, sorry, the other way around actually. Within this list, insert this element at the same level. And we should end up with 2 curves in a list, rather than having to flatten the list and then turn it back into a list of 2 elements. That's a quicker way to do it. Okay, so now we need to make a solid by loft with cross sections, and this expects a list of cross sections. So the great thing is we've created the list by doing this. So if I run this node with my 2 cross sections, I'll get a solid between those. So I'll just go and turn off my other curves so that they're out of the way. And obviously I can change my tolerance to be more, and that will feed back to my node here. So that gives us a lot of control over how far we're reaching outside our room. And obviously if your room's got a funny little outline, it will still work because it'll be a polycurve that joins the outside of the room. The only exception is if you have a room with like a hole in the middle of it, like a corridor going around, that can be a bit trickier. So I always advise that you try to build different scripts to handle those strange sorts of rooms, because they're a lot harder to deal with. This is assuming your room is just a single enclosed volume. Okay, so at that point we need to go back into our section that deals with our elements to be tagged in view. So the way this worked originally is we gather all our elements, we filter out rooms, and then we take what's left and we find out if the parameter that we're trying to tag has no value. We're going to filter it out. So we're essentially getting rid of all the elements that don't have a taggable value, such as walls and doors. So that's how we get around the tag all limitation. What I'm going to do is just move these nodes back just a little bit. Okay. But what we need to do now instead is we also need to process these elements out if they don't contain a point as their location before we check for an intersection as to whether they're occurring in the room or not. So I'm just going to move these just a little bit back to make a bit more room for them. And I'm just going to disconnect these nodes. I'll just push this back just a little bit more again. Because essentially what we're trying to do is use a node called doesIntersect to check if the location of all these elements occurs inside this room volume that we've just defined. So I'm going to take this portion of my script here, and I'm going to say all these elements that we successfully want to tag, we need to check now if they occur in the room. So we're going to get these elements location. We're going to check if their location is a point. And then we're also going to Boolean mask based on whether it's a point. And we're also going to Boolean mask their location as well. Okay, but now we need to check if these points are occurring within our room. So we should end up with a list of points in this Boolean mask. So I might just make a list create here just so you can see all the elements as they occur. And I might just hide my solid by loft temporarily. So if I run this, now you can see that we have this set of elements in our elevation. And notice how things like chairs and tables are outside the room. So these are the things that we don't want to tag. So this is great. We've actually picked up those elements, and now we can identify to Dynamo that these don't occur in the list of elements we want to tag. So we should essentially get a list of trues and falses. We need to set our lacing to longest as well, because we're taking one element and checking multiple elements against it. So this will force it to check all of them. And you can see we get some true, but a majority of them we get a false, which is what we expect. So we're going to filter these out again. So we're going to filter by Boolean mask. Brilliant. And we're going to take our elements and we're going to mask them. So the only things that successfully make it through are the elements that have a true, or the in list in this case. I'm just going to push this back just a little bit more. It needs a lot of space. The script does get quite big. I'm not being very tidy with how I'm laying it out. Of course, you can be a bit more tidy if you like. Okay, so now what we need to do is recheck the ID of these successful elements. So I'll quickly just show you which elements we have. So you can see we have our pin boards and our GPOs, our joinery and our bin. So it's successfully identified the elements that we want to tag. So I'm just going to check their element ID to see if they're tagged or not. And then I'm going to be filtering them out to the final portion of my script. And then we'll end up tagging these elements. So I'll just run this without opening this section of the script up. And there you go. We see we get our locations and we get our elements in our room in our out list. So we're ready to run the script essentially. What I might do before this is I might actually set the script up for Dynamo Player, and we'll run it through Dynamo Player instead, just to show you how you could do a couple of views in a row. Okay, so a few things we need to set as inputs for Dynamo Player. The first thing is we need to set, we don't need to set multi-category tags, but we do need to set the type of the tag. So we can just call this tag type, and this is the tag that we'll be tagging all the elements with, but also the tag that we'll be checking if elements are tagged with this tag already. Okay, so that's our first input. Our second input is going to be the parameter that we're tagging. So in this case, mine is called ABG data code 1. We'll make it an input so the user can change it if they need to make the script really flexible. So we'll just say parameter to tag. This is the parameter we use to validate that the walls and the doors don't contain any information to tag. So that's really important. Okay, if we go back, we also need to identify our room as well for tagging. So room for tagging. And we'll also add an input for the offset or the tolerance beyond the wall. So we'll just call this tolerance past walls. So the user can specify how far past the wall they want to tag. I always recommend you make this roughly 100 or 150, because remember that you might end up reaching out to GPOs or elements just on the other side of the wall or inside the wall as well. So there'll be a fine line between hitting those elements in some scenarios. So it's up to you to sort of measure and gauge the scenario of how you're tagging. Okay, but I think otherwise that's pretty much it. That should be all the inputs that we need. Cool. So we'll just go and run this through Dynamo Player instead. So I might just resave this script as something I can identify, and I'll just call it Dynamo Player. Okay, so we're gonna close Dynamo and we'll boot up Dynamo Player. And I might also just go and set up one extra elevation for tagging. Sometimes Dynamo Player can be a little bit slow to kick up to begin with, but once it's going, it's going. So I'll just set up one extra elevation for tagging, just to show that you can jump between these quite quickly. Actually, I'll just do a couple. 1, 2, 3. And we'll just visit them and cross-check that they're okay for tagging. Cool, that one looks okay. Looks okay, and looks okay. And I might just cross-check that the detail level is fine. Cool. So these look okay for setting tags too. Cool. So let's go and run Dynamo Player across these views to tag all the elements in view. Cool. So I'm just going to go navigate to my folder. As a lot of you know, I usually just work off my desktop for most of my demos. Don't do that. It's a bad habit. I just do it for my demos. Okay, so we're going to open up the inputs of our Dynamo Player script. And we're ready to start tagging. We will need to pick our room as our input. Because our default value is the room in our session, we technically don't have to, but if you're in a different model, that room doesn't exist in that model. So you would have to re-specify that room as an input. So let's just say we are in a new model. So what I'd usually do is just isolate my room, select my room for tagging, and I'm pretty much ready to go. So I know my parameter, I know my tag, and I know my tolerance. So I should only really get a tag on one element in this view, ideally. Okay, we got a couple there actually, because there's a couple of GPOs on the wall on the side. So I guess we're seeing those as well. So we've got a GPO and a data outlet in our view range as well on the side. It's up to you whether you want to tag those, I guess. You might have different standards where you work. Let's run it on our original view. Cool, and now you can see we only tag the elements that we can see. So we've got 2 pin boards and a whole bunch of GPOs. So obviously you can just go and move these tags, rotate these, and there's just a little bit of work to tidy up the view, but placing the tags is nice and easy now. Cool. If you have very predictable tagging positioning in your views, maybe you can build a Dynamo script to place it in the right location. Cool, we'll run it here, and cool, you can see we've got our 2 GPOs again, and we've got our joinery units otherwise. So brilliant. And if you know your joinery units are all sort of positioned the same way, you can just get all your tags at the same time, move them into position, grab anything special like this projector screen, and done. Look how quick it is. It saves a lot of time in elevation views. Run. And we got a GPO and all that switch. Cool. And there you go. We've just done 4 views, and we've only tagged the elements in that view, which is brilliant. And obviously you can use this for room layout sheet plans as well. So let's say in this particular view, we didn't have any tags at the moment. So originally when we tagged in this view, it tagged everything it could see. Whereas now we only tag elements in that particular room. So you'll see we only tagged this room now. So it's a much more refined way of tagging. And it makes sure you only tag things that you care about. Obviously if our tolerance is too big, say 1.6 meters, it's gonna start picking things up outside the room. So just keep that in mind. But otherwise, that's pretty much how to refine the script for rooms. So hopefully that makes sense. For the true automatons out there that really want to make these scripts very powerful, consider looking into ways to make the tags work for multiple views per room at once. So find a way to isolate all the elevations that belong to a room, for example, such as finding all the elevation markers inside a room and visiting them all using the script. Obviously much faster, and you could tag an entire room layout sheet in one script if you did it right. I won't build it for this one because it's quite specific, but just keep it in mind, and keep in mind that data shapes, a custom package, has a node which will help you called all elements in views. Okay, so in the next video, we're going to add a user interface to the back end of our script. Let's say we only want to tag our GPOs in my particular view, or we want to tag all but one particular thing. We want to build a user interface where the user can opt to pick a few things only. Okay. But otherwise, that's all for today. So hopefully that helped. If you've got any feedback or comments or queries or suggestions, feel free to leave them down below. Always happy to collaborate and hear from other people. I get quite a lot of feedback from people now, which is great. If you're not already following and subscribing, feel free to do so. And hopefully I'll see you in the next video. Thanks. Take care. Bye.